So over the summer, what you're going to learn is basically integration. Can you guys all see the screen? So integration, and another topic is, I'm going to zoom in a bit, okay? Another topic you will have to learn is statistics, okay? And probability. Okay? So, shall we do integration today or probability today? Okay, let's just finish integration and then we'll move on to statistics maybe next week, okay? Yeah, so let's begin. Let me just paste this one here. Alright, so I think Osbert, last time you learned these stuff. So these are the rules. So if you look carefully, so if you integrate x to the power of n, you get this one. Another way of writing that down is x to the power of n plus 1 over n plus 1. So more commonly it's written like this. You know what differentiation of e to the power of x is? Well, this is e to the power of x. So integrate that, you get e to the power of x. Because if you differentiate this, you get this. You know, going this way is differentiation, and this way is integration. So it's just opposite. So we know that differentiation of ln x is 1 on x, so therefore integration of this is this one. And you know, what's differentiation of sine? It's cosine. So integration of cos is sine. Okay, etc., etc. So you all get this one, this file. So I'm just using this textbook here. So this is integration 2. June, you'll have to do chapter 14 as well, because he did chapter 14 already. Okay. So today we're doing integration 2, further techniques. For specialist class, you'll be doing more calculus in session 2. Okay. So let's have a look at this. So I'm just going to copy this one here. Alright, so let's take a look. So if I want to integrate sine 2x, we know that you have to put this symbol here and this symbol here. So these two symbols here, they represent integration. Okay? So this means I'm just integrating this part here. So if I integrate sine, what should I get? I should get negative cos. Okay? Negative cos. Okay? Because what's differentiation of cos? It's negative sine. So therefore, what's differentiation of negative cos? Sine. Okay? So you have to put it's negative cos and 2x here. Okay? But June, think about this. Okay? When I differentiate this, I get sine 2x. But then there's something else you have to put as well. The 2 comes out to the front. Okay? So therefore, in this case, I have to divide this by 2. So in differentiation, you put 2 in front of it, so you multiply by 2, but in integration, you put it under. Okay? So that's all. And then you have to put plus c here. So whenever you integrate, you need to understand that you always put c. That is just a constant. Okay? So, let me just get the size of my eraser bigger. Why is it so small? Okay, anyway. All right. Let's talk about integration of x to the power of 2 dx. So this integration of just this bit here, okay? So if you integrate that, you just raise the power by 1, so this becomes x to the power of 3, and just divide that by that power, okay? 3. So see when you, and plus c there, okay? So when you differentiate this, 3 comes out to the front with the 3 here, and this 3 and this 3 will cancel out, right? And then this will turn into what? 2, is that right? So therefore you get x squared. And when you differentiate constant c here, this will just disappear. Understand? Now, what about this one? Integration of 2x plus 5 to the power of 6 dx. So let's suppose you're differentiating it. If you differentiate it, 6 comes out to the front with the 2x plus 5 to the power of 5. And then there's something else. Because this is not x. If this was just x, if this whole thing was just x, then you get, if this is a x to the power of 6, then you will get 6x to the power of 5, right? But if you have 2x plus 5 to the power of 6, and you differentiate that, then you get 6 to the front, and this whole bracket to the power of 5. Well, that's exactly the same method as this one, right? But then because this bracket is 2x plus 5, you have to differentiate the bracket as well. So, June, are you familiar with that? Sorry? So 2, yeah. So this becomes, you have to multiply by 2. Okay? So therefore, it becomes 12. Okay? So that's 12 here. And that's everything. So that's differentiation, right? But in integration, we just do the opposite. Instead of multiplying by 2, we just divide by 2, okay? So take a look. So this one goes 2x plus 5 to the power of 7, and you have to divide by 7. That's just part of the rule. Yeah. And then there's 2 here, so you just put 2 under, okay? And that's everything. And then you have to put c there. So that becomes 14 down there, and you have 2x plus 5 to the power of 7 plus c. So yeah, if you try to differentiate this, then you will see that you get this one here. All right, that's everything. Okay, journey finished. Yeah, this will be on YouTube as well, so you can look at it again if you want. Now I want to talk about differentiation of ln x. And there's an absolute value sign because you can never have a negative value in here. Okay, so if you differentiate that, so let's say this is y, and what is y dash then? What's y dash? It's simply just 1 on x. Okay, so what is integration of 1 on x? By the way, this is an s, but it's a bit longer than s, right? Yeah, so this means integrate, and you always have to put dx here, okay? Yeah, so if you integrate that, of course you're going to get ln x, and then what? Plus c. Let me ask you this, how do you integrate this? It's 1 on 2x. There are 2 ways of, I have to put dx here. So you can consider this as a bracket, right? So this becomes ln 2x, right? And then because this bit is no longer just x, it's 2x now. What's differentiation of 2x? 2, so you just put 2 down here. Okay? Plus c. However, there's another way of doing it. Just take the 2 out of it. So this becomes a half. You can take the half out of it. And this is integration of 1 over x. And then dx. Is that right? Is half times 1 on x? Because any constant can come out of the integration. Okay? But turns out This one is a little bit different. You got half here, and then you got ln x there plus c. Well, this is ln x over 2 plus c. Is this the same looking as this one? Looks very different, right? So which one's correct? Can they be both correct? Give me some answer. Response. Come on. Well, was this wrong? Any method here? Was it wrong? Well, it wasn't wrong. Was this one wrong? The answer is that they can both be right. But the truth is, this C here and this C here are not the same C. This is actually a preferred method. Okay? The reason is, look at this one here. That sort of separates out into, so you can, did you know that like absolute value of 2x is the same as 2 times absolute value of x, right? And when you have ln 2x like this is equal to ln 2 and absolute value of x. But if you know what the logarithmic rule, this separates out into log of 2 plus log of absolute value of x. Is that right? So what happens here is this separates out into this over 2 plus ln 2 over 2 plus c. Okay? And this whole thing is the same as this c here. Okay? So in fact, I'm going to let this one capital C, like this. So this C here is different from this C. And this C plus this ln 2 on 2 is equal to this C here. Okay? Anyway, just use this one. Use this. Do this method, okay? Yeah. You don't need to have this 2 inside here. You can take it out of it, okay? So why bother doing this method when you can do it like this? However, when it comes to integration of 1 over, let's say 2x plus 1, actually you don't need the bracket here. Okay, so it's 2x plus 1. In this case, we can't do it like the one we did here. Okay, you can't take the 2 out of it. Okay, because this 1 here is not does not have 2 as its factor. You see? So this 2 cannot come out of it. So in this case, you have to do ln absolute value of 2x plus 1 over 2 plus c. So that's fine. Okay? So this method is pretty much the same method as this method here. Right? So you need to know this. Okay, when it's a single term like 2x or 3x, then you use this method. Okay, you take the 3 out or 2 out. Okay, take it out of it, and then do the integration of 1 on x. But if it's like this, 2 terms inside the denominator, then you have to you can't take the 2 out of it. So you just integrate this whole thing and put all of this into the ln and then divide by 2. Okay, so that's the way you should do it, like this one here. Okay, so this is 1 over like x, right? But instead of x you have 2x minus 1. So if anything is 1 over something, I would say linear. not quadratic, then that becomes ln. Okay? Yeah. All right. I'm going to rub it off. It's very easy to rub off. The whiteboard is very difficult. Okay, I want you to think about this one here. Integration of 1 over x squared dx. Okay? Is that equal to ln x squared plus c? Osbert? June? No, it's not. Okay? It's only when you have a linear function here. What's a linear function? Like mx plus c, okay? Anything that looks like this, then this becomes ln x, okay? ln stuff, okay? Okay, how do I get my eraser bigger? That's opacity. Maybe it's this one. Alright, I want big eraser. Actually, we can rub it all off, okay? Okay. So when you have 1 on mx plus c, or b, this is the one that becomes ln, okay? When it's a square, it's something else. Okay, so if you have integration of 1 on x squared dx, you should know that this is the same thing as integration of x to the power of negative 2 dx. Is that right? So this becomes, you just follow this rule here. This one right here. That's the easiest rule out of integration. You just raise the power by 1 and divide by that power. So it's already integrated. So this becomes x to the power of negative 1 over negative 1 plus c. So this becomes just negative x to the power of negative 1 plus c, or negative 1 over x plus c. Now, let's talk about this one here. Integration of e to the power of 2x dx. Well, that's equal to e to the power of just 2x over 2 plus c. Okay? So if it was just e to the power of x dx, you would get e to the power of x plus c, yeah? So, therefore, you just do it as if it's just this, which is this one here. And then, because it's 2x, you just have to replace it by, just divide by 2, which is differentiation of the bracket. So that's really simple. We're going to skip this one. You can try that as well on your own. Now, we're going to talk about what's called integration by substitution. Okay? All right. Integration by substitution. Let's say you have integration looking like this. Let's say you have that. Write it down. It seems like it's just, we're just using this rule here. This rule here. I'm going to write that down over here. So if you have x to the power of n dx, that's just x to the power of n plus 1 over n plus 1 plus c. You just raise the power by 1 and then divide by that power. Okay? But how would you do this one? I do not want you to expand it out. But of course you can expand it out if you want. Okay? If you expand it out, then this becomes like, it's really messy. X squared, this one is going to be like, what's x to the power of 3 to the power of 3? 9. Is that right? Is that right? Yeah, x to the power of 9. Plus, like 3x to the power of, actually 9x to the power of 6 plus, and then what's next? 3 times x to the power of 3 times 3, so that's also 9, and then 27. So this is 9 here. So it becomes this. And then you can expand it out into x to the power of 11, 9x to the power of 8, plus 9x to the power of 5, plus 27x to the power of 2, and then dx. And then you can use it using this method here, 13 over 13, 9x to the power of, well, not 13, 12 over 12. You just raise the power by 1. 9 over 9, so this 9 and 9 cancels out. 9x to the power of 6 over 6, and then x to the power of 3 over 3 with 27 here. C. But that's really taking a long time. So we're not doing that, okay? So how do we do this thing here? I'm going to rub it all off without expanding it out. So if you look at this bracket here, pay attention to that. If you differentiate it, you see how this is cubic? So if you differentiate it, what do you get? You get quadratic function, right? But do you see the quadratic function outside? So whenever you see something like that, when the differentiation of the bracket sort of exists outside of it, then you can integrate it by substitution. So I'll show you. This is how you should do it, okay? You just simply let some u, so that's another symbol, equals to the bracket here, okay? That. And then do du dx. What do you get for that? Differentiation of u with respect to x. You just get 3x squared, is that right? And then this whole thing, I'm going to rub this one off. And then this whole thing is going to look like this. Integration with this bracket here, that's going to be u to the power of 3, is that right? But then I have x squared dx. So have a look at this part. So I let this equal to u, and I differentiate it, and I get 3x squared. So that means 1 over 3 du dx is equal to x squared. Is that right? I just divide both sides by 3, then I get this. June, do you understand? And then let's multiply, let's just move this dx to the other side, then I get 1 over 3 du equals to x squared dx, is that right? Well, this and this was x squared and dx, right? So I can simply replace that with, so I can replace, I'm going to use a red pen here, so that bit and that bit is this bit. That can be replaced by this dude here, okay? So that's equal to 1 over 3. I'm going to put 1 over 3 here, and then du here, okay? So that gives us, so you can, what can you do with the 1 and 3? Osbert? what can you do with the 1 on 3? Take it out, right? So you can take it out. And an integration of u to power of 3 du. So now, June, can you integrate u to power of 3? 4 over 4. Very smart. So this is equal to 1 on 3, u to power of 4 over 4, okay? Notice how, look guys, u is equal to x to the power of 3 plus 3, is that right? So if I integrate that, you may wonder, oh, shouldn't I differentiate that bit as well? And then like put it under, but you don't have to, because in this case, it's integration of u with respect to u. So if I have integration of like x to the power of 3 dx, I can just do this as x to the power of 4 over 4. Is that right? So what if I have, I want you to take a look at this. What if I have integration of like 2x plus 1 to the power of 3 dx? How do I integrate that? It's a 2x plus 1 to the power of, it's a little bit different, right? 4 over 4 and then 2. Is that right? But watch this. If I have integrate 2x plus 1 to the power of 3, and then instead of dx, if I have d, this is a bit weird, 2x plus 1, okay? Then this simply becomes 2x plus 1 to the power of 4 over 4. You don't need the 2. We are treating this whole thing as if it's one variable, and there's just variable here. Okay? So that's the weird bit about it, okay? Yeah. So therefore, if you have u to the power of 3 and du, whatever the u is, it's just integration with respect to u. So you don't need to do anything about this point here. So you don't have to put the differentiation of u down under here. It's just u to the power of 4 over 4. That's it. Okay? And then there's a plus c there. I'm gonna rub all of this off. So you can now rewrite the whole thing as 1 on 12, and then this is a u to the power of 4, right? So the u to the power of u is equal to x3 plus 3, x3 plus 3 to the power of 4, and then there's a plus c there. Okay. So let me just write something here. When differentiation of f of, when I would say f dash x exists as well as f of x, then you can use this method. Okay, which is method of substitution. Method of substitution. All right, let's have a go with another one. Let's have a go with another one. Okay. So actually, you can see if this one differentiates to this one. Can we try that? So if I differentiate that, don't worry about the 12. The 4 comes out to the front, so it becomes 4 on 12. X to the power of 3 plus 3 to the power of 3. And then you have to multiply by the differentiation of this bit, right? So it becomes a 3x squared, is that right? So you see 4 and 3 with the 12 cancels out, because the 4 times 3 is 12, and 12 and 12 cancels out. And you see that how this is what? Exactly the same as this one. Right? Okay, we're going to move on to another one, okay? Let's say you have integration of sine x cosine x dx. Sine x cosine x dx. Now this is weird. We know what the integration of sine is. That's negative cos. And integration of cos is what? Sine. But this is integration of sine multiplied by cos. Okay, and just need to know this. There is no product rule. There is no quotient rule in integration. Those only apply to what? Differentiation. So what you need to do is, can you actually see that differentiation of sine is cos? So this is like it has a look of f of x there, and then f dash x there, and then dx there. So what did I say in the previous slide? Whenever you have f dash x and f of x in there, you can use method of what? Substitution. Okay? So what you can do is let u equals to sine x, and just differentiate it. Du dx is equal to cos x. But from now on, I'll actually do it like this. Instead of doing this, I'll go straight to du equals to cosine x dx. I'll go straight into that, okay? So I'm going to actually jump from there to there straight away. Okay? Now, well, this can now be written as integration u, and this whole thing is just du. Oh, that's very interesting. How do I integrate that? That's a u to the power of 2 over 2 plus c. Okay? So this turns out this is equal to sine square x, because u is equal to sine, over 2 plus c. So that's it. You can see if that differentiates to this. You can try that as well. Okay, what should we do next? Yeah, let's try this one as well. I want you guys to try this one on your own. I'm going to copy this and maybe paste it here. So we're doing this one. So which one should you let equal to u? That's what you need to think about. This is integration of, I think, e to the power of I would let u equal to this power here. So u is equal to 2x squared plus 2x. So therefore, du is equal to 4x plus 2 dx. Like this. Well, we don't quite have a 4x plus 2 inside here. We have instead half of that, 2x plus 1. Okay? So this turns out is equal to, so you can actually manipulate a little bit here. So what I'm going to do is divide both sides by 2. Okay? So I put half here. So half du is equal to 2x plus 1 dx. Is that right? So this whole thing can be e to the power of u. So that's e to the power of u here. And 2x plus 1 dx is equal to just half du. So half here, half du. So that becomes a half. And then e to the power of 2x squared plus 2x plus c. Okay, let's actually go back to, so that's the answer. So you can differentiate it and see if that becomes this. Let's go back to this question right here. Hold on, it's not going anywhere. So integration of sine x cos x dx. So we let this one equal to u, and this whole thing, so this was the u dash, right? But now let's try and let this one equal to u. Okay, so we'll do that and see how this one changes. So when we did sine x cos x dx and let this one equal to u, what was the answer? It was a sine square x over 2 plus c, yeah? So that was the answer. So now instead, I'm going to let this one equal to u. So u is equal to cosine x. What is a du? Du is equal to negative sine x dx. Is that right? Now, if I just minus both sides here, then I get negative du is equal to sine x dx. Is that right? So this whole thing can be integration with that's u here. That's u. And sine x dx is nothing more than negative du. So that's a du here with a negative sign there. So this becomes negative u squared over 2 plus c, and that's equal to negative cosine square x over 2 plus c. Is that right? So is this the same as this one? Well, you should know that both of these are correct answers. Okay, so either method is fine, but how they actually related? You guys know that like sine squared. Let's actually see. So these two, both of them are correct answers, but I want to see if this c is the same c as this c. Okay. We know that sine square x plus cosine square x is equal to 1. That's from session 2. So I'm going to actually plug in, well, sine square x is equal to 1 minus cosine square x. So I'm going to plug this one in here, okay, and see what we get. So therefore, if I plug that in, then I get a 1 minus cosine square x over 2 plus c, and that becomes, oh, that looks sort of similar to this one. So that's equal to half minus cosine square x on 2 plus c. Well, this bit is the same as this bit, but you can see that there is extra half here, and this bit is equal to this bit, right? Yeah, that's another constant. Half plus c is another constant. So you can see that this c and this c are different, but they're still c, okay? Constant. So you can do either, okay? Anything is fine, but it's just that that c and that c are different c's, okay? This one is half more than the c, right? Now, so that was integration by substitution. Okay. I would like you to try like this one here. You can see that somehow if you let this one equal to u, you get that automatically, right? So I want you to try this one. Now I'm going to pause the video a little bit.